So this unit, we are going to talk about a specific type of histogram that we looked at in last class, last unit, but it's just going to be our only focus for this unit. It's called a normal distribution, a normal distribution. And you guys know what a normal distribution looks like. It's this symmetrical distribution that we've kind of looked at before. And we can go ahead and sketch one right on here. A normal distribution, let me use the correct color, is a distribution that looks like this. Right? Just our symmetrical hump. The mean is in the middle. And it's going to be the same as the median. You can do a better job of sketching it. So you're just a little bell-shaped curve. Okay. And what we do when we do these curves is we are fitting a density curve to a histogram. Okay. So we have these data sets here. It doesn't matter what they are, but we have histograms with frequencies. These frequencies, you know, the total amount of doctorates between 0 and 5 is this many. Total amounts between 5 and 10 is this many. And what we do is we can kind of draw a density curve right on top of that, just so that we have a general understanding of how our shape of our data appears. Okay, and we should remember that this over here, this would be a data set that would be what? Skewed right, exactly, skewed right. There's different ways to remember that we are skewed to the right. The way I like to remember is that since we'll have outliers to the right, the mean is going to be to the right of the median. All right, well, here is another histogram of just frequencies of stuff. I don't know exactly what it is, but when we kind of sketch this density curve over it, we can see it's that bell-shaped symmetrical curve. This is our normal distribution. Right? Now, what do density curves do? It kind of changes things up. Instead of having a histogram, which is just frequencies, these density curves show proportions or percentages. Kind of like, what if instead of having a finite amount of data points, what if we had an infinite amount of data points? Okay? And if we had an infinite amount of data points, where would our data kind of lie? So instead of showing counts, which is what the histogram bars are, the frequencies, proportions are going to show percentages, or these density curves will show percentages. So an example for this one here, if we have a normal distribution, we know 100% of my data points will lie underneath that curve. We'll have, you know, data points from whatever starting value to whatever finishing value, and we'll say 100% of our data will be under there. Okay. So it kind of just it just makes it easier to look at, and it just, you know, naturally kind of increases our sample size. So instead of having just, you know, a histogram with a certain amount of frequencies, we have, you know, an infinite amount of frequencies. Okay, and we should know how to do means and medians of these curves just by looking at it. So here we're skewed right. We know the mean is going to be greater than the median because the outliers are going to be over here to the right. Here for a normal curve, the mean and the median are the same because we'll have outliers maybe on the left and the right, but they're kind of even each other out. Okay, so this is very important. Now, we used like the interquartile range, and we used the median when we describe things that were skewed. For normal distributions, we are going to focus on the mean and the standard deviation. These are the most important things when talking about normal distributions, the mean and the standard deviation. So we're not going to worry so much about the median here, because we know the median is going to be the same as the mean. but we will find out that the standard deviation is going to do a great job of helping us describe where our data points are going to be between. Okay? Whereas for something that's skewed, standard deviation, not as effective, not as useful. Okay? I'm going to skip this really quick. Here's our normal curve. It can be tall and kind of skinny if our standard deviation is smaller, or it could be short and fat if our standard deviation is greater. But they're both normal curves, these bell curves, okay? And here's some characteristics of normal curves. We know they're symmetric, we know they're bell-shaped. The tails are going to fall off quickly, so we will kind of have outliers, but they're going to be on both the right and the left. They're not significant outliers that would be skewing my data. Right here, the point at which the curve changes, we're kind of going from concave down to concave up. This is going to be one standard deviation greater than the mean, plus one standard deviation. And right here, this would be plus one standard deviation. Okay? And what are we going to use to describe normal curves? The mean, which is the center, and the standard deviation is what we're going to use for the spread. That means on the other side right here, this would be minus one standard deviation. Okay? Don't have to write everything down. We know the mean and the median are the same. We know we're bell-shaped. It's this that is key. The mean is what we're going to be used to describe the center. The standard deviation is what we're going to use to describe the spread. We won't talk about the range, the interquartile range, the Q1, the Q3 value. We'll be able to calculate where the Q1 and the Q3 value is, but we'll kind of just go from there. Okay. We're going to come back to this. Drawing normal curves, okay? Let's say I have all of these presidents, okay? And these are all the presidents and their ages of the presidents during their inauguration, okay? Let's say I went ahead and I plugged that into my calculator, and I found the mean of the president's age was 60, and I found the standard deviation of the president's age was 7. And I find out that when I look at the president's ages, they are going to follow a normal distribution. Okay? What I'm going to do is be able to sketch a normal curve, because I'm going to be able to figure out how old I would be if I'm one standard deviation greater than or less than the mean. And I could do the same for 2 standard deviations and 3 standard deviations. Okay? So, if 60 is the mean and 7 is the standard deviation, what would be the value if you are one standard deviation greater than the mean? 67, exactly. We just add the standard deviation to the mean, and all of a sudden, we have 67. Well, that means minus one standard deviation would be 53. Okay, you guys do the same thing for 2 standard deviations and 3 standard deviations. See what our ages would be. 60 and 7. All right, what would be 2 standard deviations greater than the mean? 74. What would be 2 less than? Good. And then let's go to 3 plus 3. We'd go all the way up to 81. Minus 3, we'd subtract 7 from 46, and we'd get 39. Okay? What we can do is sketch a normal curve using this information. Okay? Here is what our normal curve will look like, and here is very, very important rule that we will learn. Before we're going to talk about this important rule, I want you to sketch a normal curve, and we are going to plot our values, where they fall, compared to what our standard deviations are. Okay? So I'm going to sketch the age of President's inauguration. Okay? If this is a normal distribution that we sketched down, we would say right in the middle was 16, right? Well, each standard deviation is going to be the same kind of distance. It's all a distance of 7. Well, one standard deviation greater you can list as 67, 2, 74, 3, 81. And we will be able to kind of sketch our distribution for the age of presidents in this case. Okay? These values correspond with these numbers, and these numbers are the standard deviations away from the mean. Okay? Now we have that down. Here's where normal distributions are great. No matter what your data set is, if it's normally distributed, the percentage of your data points will always follow this empirical rule. Okay? So we have age of president's inauguration, when they're how old they are when they were first put into office. If I had something else that was normally distributed with maybe a different mean and a standard deviation, these percentages would still be true for that other distribution. Okay? And here's the key. Here's the beautiful thing about normal distributions. 68% of the observations will fall within one standard deviation of the mean. 95% are going to fall within 2 standard deviations of the mean. And 99.7% of the observations are going to fall within 3 standard deviations of the mean. So long as your data is normally distributed. And you should write these down and go ahead and sketch this. Okay? For our example that we're using, our president's example, we would say 68% of the presidents were between 53 and 67 in terms of age when they were inaugurated. Here, we would say 90% of all of our presidents are going to be between 46 and 74. And we would say 99.7% of our presidents are going to be between the age of 39 and 81. This is the empirical rule of normal distributions. 68, 95, 99.7. Definitely write down these three if you haven't gotten them down yet. Now, let's go and look at our data really quick. I'll give you a couple extra seconds so you can have this down. The actual mean was 54.6, so where I was actually off with my guess. And the standard deviation was 6.2. So if I adjusted to 54 and 6, we would have been able to find that our data would have also, our sample data would have followed this, overall kind of population data, infinite amount of data, okay? Which is cool. Now, what's great, if we know this, we will know the percentages within each of these standard deviations. And I want you to either take a picture of this or write this down. Because what you know, if you have 68% between -1 and 1, that means 34% is going to be between 0 and 1 on both sides. And then between 1 and 2, if you have 95%, well, 95% divided by 2 is going to be 47.5. Well, if that's 47.5, I can take 47.5 and subtract 34 and get 13.5. So all of a sudden I know that 13.5% of my data will fall between 1 and 2 standard deviations of the mean. And all of a sudden all of these little sections we can know the percentages for. And this is very, very excellent and useful information that we can use when we're answering questions involving data sets that are normally distributed. Okay, so let's look at some other things that are normally distributed. And what we have now is the power to kind of describe data using these percentages to figure out, what our data should probably fall between. Take the SATs, okay? SAT scores are approximately normally distributed with a mean of 500 and a standard deviation of 100. Go ahead and just make sure you write down SAT, write down the mean is 500 and the standard deviation is 100. So that means if I took a sample of SAT scores on a certain subject in this entire school, I would see this normal distribution if I produced a histogram, okay? Well, we can sketch the normal curve with our mean and our standard deviation for SAT scores. Why don't you go ahead and do that? Sketch your normal curve for these SATs. We'll have all these tick marks that are going to be very important tick marks, like the one in the middle. What should be the value that I put in the middle? 500, the mean, exactly. Well, we will use the standard deviation plus one standard deviation minus one standard deviation to kind of sketch our other kind of tick marks, where we have all of our kind of our data samples in between those in terms of percentages. So what would be the one to the right of 500? 600, right? Because we have a standard deviation of 100, and if I add one standard deviation, I'm going to be at a value of 600. Two standard deviations would be 700, all the way to three standard deviations, which would be 800. And then I'm going to go ahead and fix my curve just so I know that we should be really, really tailed off when we get all the way to 800. Kind of like that. Okay? That means to the left we'll have 400, 300, 200. And we'll understand that we can be 4 standard deviations away from the mean. We could be 5 standard deviations away from the mean. However, since we know, if you're normally distributed, 99.7% of your data is going to lie between -3 standard deviations and +3 standard deviations, we don't have to go out to 4 and 5 and 6 standard deviations, because it'd be too much. We wouldn't have any data points there. So that's why we kind of trail off to almost 0 when we get there, okay? Okay. So now that we've kind of sketched our normal curve, and we know our percentages in between all of these standard deviations, we can answer the following questions. Like, what 50% of scores lie below what score? Ms. DeVries? 500, right? The mean, which is also the median. Okay? If I looked at just values below here to the left, and I added up all my percentages, it's going to be equal to 50%. Okay? Which means I know 50% of my data is going to lie above 500. Okay, well that's easy. If we know the median and the mean are the same, those two questions are easy. But here's a couple other ones, like 68%, and you can say this confidently, of our scores are going to fall between what two scores? Mr. Morris? 400 and 600, because we know that normal distributions, 68% of our data is going to lie within one standard deviation of the mean. So 68%, one standard deviation. One standard deviation underneath is 400, one standard deviation above it is 600. What percent of scores would fall within 500 to 700? You guys figure that out. Talk with your neighbors. See if you can figure out what percentage of over total scores of everybody who's taken the SAT fall between a 500 and a 700. You get it? You do. You have all of your percentages, right? Between 500 and 700 is between what standard deviations? Between 0 and 2. Okay? What we're going to do is between 0 and 2, we're going to look what percentage of our data is between 0 and 2. Okay, so what is that? Between 0 and 2, how much percent of our data is there? Between 0 and 2 standard deviations is all of this data. Okay, and we can figure out the percentages of that data, because I know that between 0 and 1 is 34%, between 1 and 2 is 13.5. Just add them together, exactly. So what's our answer, Mr. Riley? Yep, what's 34 plus 13 and a half? 47.5. We just answered that, which is fantastic. Okay, so you know that, hey, values between 500 and 700, 50% of all students who took the SATs fell between 500 and 700, about 57, 47 and a half. Well, what about just between 600 and 700? 13.5, right? If you look at your graph, you see between 600 and 700, that's between 1 standard deviation and 2 standard deviations. This area here is 13.5%. So if you scored within a 600 and 700, you're within 13.5% of the population who scored there, okay? Now, last question, what percentile is a student who scores a 700? Now, when I ask you what percentile, that means how much is below your score, or how many students scored below what you got, okay? So that means you are better than this many students, okay? So percentile is percent below, okay? You guys can figure that out, right? Figure out what percent is below a student who scores a 700 using your calculator and using these percentages that we figured out and that we either took a picture of or plotted down. What do we get? 97.65. How did you get that, Miss Jameson? We got 97.65. You added 50. Good. Perfect. So we know below the mean is 50%. That's awesome to know. We already did that. We also know between 0 and 2 is just 34 plus 13 and a half. That's 47 and a half. We add 50 and 47 and a half, and boom. We get our answer, 97.5%. So that means if you scored a 700 on one of these subjects on the SAT. Do you guys take the SAT or do you guys take the ACT? Take the both? I took the SAT only. If you scored above a 700, you were in the 97th percentile, which means you were better than 97.5% of all students who took the SAT. Which makes you feel good, which is why you probably go to a good school. Okay? We will be able to take your specific score. Let's say we scored like a 650. We'll be able to take your specific score in the future, and we'll figure out what percent of students scored below that. Okay? We'll be able to calculate how far away you are from the mean in terms of standard deviations. We'll be able to use our calculator to figure out what percentage is going to be below, which is really powerful stuff. It really tells us a lot about a lot of things. Okay? Here's what your thing looks like. This is exactly what we did if we were below 600. We'd add 50% of the scores and 34% of the scores. If you got a 600, you would be in the 84th percentile. Okay? Albums. The playing time of albums are approximately normally distributed. The average time in a large collection of albums is 35 minutes. The standard deviation is 5 minutes. Go ahead and sketch your normal curve and then answer the following questions. Whoops, go back. Almost there. Okay. We have a lot of people asking. 0988 1736 1541 5991 5205 6106 7052 7652 8275. If you're one of those members, get your quizzes. Anybody else with one of those numbers that I just called out? We can't be missing that many people. Who are we missing? We're missing Miss Martinez, Mr. Herzberg. I'm not sure how many quizzes he took. Mr. Meyer. Does anybody sit in front of you, Miss Pushman? Then who are you guys? Okay, check your answers with neighbors. I should be seeing the curves with the correct values plugged in. Excellent. Make sure you know the mean, and then you'll have the +1, -1, which is what we got. And then you just kind of go with your percentages from there. Now, we will have to have these percentages memorized. You will be able to produce all of the little bottom sections yourself. You're going to have to figure out how to do that because the easiest numbers to remember are just 68, 95, and 99.7. But just for you guys to know what to do, I gave you all of those sections which you can use. Really tough to sketch curves. Now, your challenge would be to answer these questions without looking at your chart, right? That would be your challenge. That would be what I kind of expect you to do by the time we get to the test. Okay. Next class, I will be producing probably the 68, 95, 99.7 chart, just so that you have those values. But you should be able to answer a question like, what percent of CD times are between 25 and 30 minutes without having anything else besides 68, 95, 99.7. Okay. What is the answer for, what's the answer for the first one, Ms. Berg?
30 and 40.
Good, 30 and 40. If 35 is our mean, one standard deviation less and one standard deviation greater, 68% are going to be between there. That's the first number on our empirical rule. If we're normally distributed, we're going to lie between one standard deviation and another. Now, here's how we could do between 25 and 30. What's the answer, Mr. Englander? What'd you get for that?
13.5.
Okay, because that is between -1 and -2 standard deviations. Now, what you can do to be able to get that value, 13.5%, is you say, okay, 2 standard deviations of the mean to the right and to the left, that is 95. Well, if I take 95 and divide it by 2, that'll be between 0 and -2. Okay? What I'm going to have to do is subtract between 30 and 35, which is 1 standard deviation away. Well, if I have 68% between 30 and 40, I'll take that 68 and divide it by 2, and then all of a sudden I will be able to get just this piece right here between 25 and 30. Okay, so we get 45 minus, we get 42.5 minus 34, and if I subtract 42.5 and 34, this is 41. No, whatever. I don't even have to do that. This is going to be, is it going to be 13.5? No, it's not.
I'll use that other, for those other percentages, not like a overall thing.
They are an overall thing. I'm just trying to figure it out. I'm messing up here. Let's see.
Yeah.
No, that's for everything. It's for everything. 13.5 is correct. We should do 95 divided by 2 minus 68 divided by 2. I must have done my math incorrect. There you go. Thank you. 47.5 minus 34. 47.5 gives you that 13.5. Okay, so I can do that without knowing all my little things. And Mr. Englander, you are correct. All those percentages that we see are for every single data set that is normally distributed, which is awesome. It's great. This is why standard deviation and means are so powerful, so long as things are normally distributed. Okay? All right. What percent of the CD playing times are below 30%? Well, here's what I'm going to do. I'm going to say, okay, 50% is below 35. So I know 50% is below 35, and I'm just going to subtract off between 30 and 35, which I know is 68 divided by 2, which is 34. And when I do that, I get 16%. Did you guys get that? Right? You guys probably looked at just the values, right? But you can think of different ways to calculate this. Okay, a playing time of 45 minutes corresponds to what percentile? So 45 minutes, we know that 50% is going to be below 35, so I got that. And then I'm going to add, I know 95 is going to be 2 standard deviations. I'll take 95 and divide it by 2. That's 47.5. So 50 plus 47.5 would be 97.5. Did you guys get 97.5? Okay, playing times of 40 minutes corresponds to what percentile? Same thing. I'm going to just take 50%, which is below 35, and then I'm going to add the 68th percentile divided by 2, which is 50 plus 34. I get 84. Did you guys get 84? All right, so right now it's easy to look at your chart and just be able to look and add up all your percentages. Here are different ways to do it so that as long as you know 3 values, 68, 95, and 99.7, as well as 50% higher and 50% less than, you can calculate these values without the chart. you will need to be able to calculate these values without the charts, okay? Unless you can memorize the chart, and then good for you, okay? That's the basis of this lesson. Anything that's normally distributed will follow this histogram, this density curve, okay? And these three should be memorized, and it's up to you how you want to go about getting these. If you want to try to memorize these down here, it might make calculations easier, or you could figure out how to use these three as well as this and this to your advantage. We're going to watch a movie to show you why normal distributions are so great and why we can look at so many things that are normally distributed and use this to our advantage, okay? After that, we will start our homework. I want us to kind of work through these. It's going to be simple as long as we understand this kind of concept on normal distributions and how great they are. Any questions so far? We did the SAT example. We did the CD example. Yes. Here comes the video. If you're watching the video, the video is not going to be on this video. So I will show you where to find it if you want to watch the video at home. You will go to this Learner Against All Odds, Unit 7.